When you have several logarithms with the same base, you can combine the logarithms into a single one, but by using the laws of logarithms. And the first one that we usually use is this one, the one that allows us to, instead of having this as a coefficient or a multiplying factor, we're going to bring it inside of the logarithm as the exponent of the argument. So on this one, c would end up inside of the logarithm as the exponent of the a, like we see over here. So if we have 3 times the natural logarithm of s, that 3 can become the exponent of the s. So you can write the natural logarithm of s raised to the power of 3. Then 1/2 can be the exponent of the t, so that's the natural logarithm of t, and the exponent as 1/2. And then minus, and the 4 will become the exponent of the binomial, the whole binomial. So this is going to end up as the natural logarithm of t squared plus 1, and then a 4. Then what I would recommend is that you don't have, that you avoid having this kind of exponents, because that can be written as a square root. So this will become the natural logarithm of s raised to the power of 3 plus the natural logarithm of the square root of t. If you feel comfortable having it like that already, or you can do it later on the process, and this is the natural logarithm of t squared plus 1 raised to the power of 4. On this step, we're going to use the other 2 laws of logarithms. And basically, when 2 logarithms are adding each other, we have a sum of logarithms that ends up as a single logarithm multiplying the argument of those 2 logarithms. And you have, when you have 2 logarithms and you're finding the difference of those 2 logarithms, you're going to use a division. So let's do the first one, and that will get us a natural logarithm of s to the 3rd times the square root of t. And we can leave this one as a second step, or you can do it all together. But now on this step, the 3rd law is a bit more evident, because we have a difference, the difference of 2 logarithms, and that means that the one with the minus will end up inside of the logarithm, but the argument will be dividing what I already have in there. So the natural logarithm of s to the 3rd power times the square root of t divided by that whole thing, the binomial to the 4th power. So that's t squared plus 1. And that's it. That's how you put everything. I forgot the exponent raised to the power of 4. You put everything together. You can do it everything at once, or if you feel more comfortable, you can do it step by step.